In the last episode, we cracked the secret. AI works by finding patterns, then predicting what comes next. But that raises a bigger question. How does it learn those patterns in the first place? And the answer is simpler than you'd ever expect. Because here's the strange part. An AI doesn't start out smart. Before training, it's basically a blank brain, a giant tangle of random connections, wired up to do absolutely nothing useful. So how do we get from that random mess to something that can write, draw, and answer almost anything? Through a process called training. And once you see it, AI stops feeling like magic. Here's the whole thing in one picture. We show the AI an example, say, a photo of a cat, and ask it to guess what it is. At the start, it has no clue. Its answer is a total shot in the dark. And that's where the real trick begins. Learning is just 3 steps, repeated forever. Guess, check, and adjust. That tiny loop is the engine behind every AI on Earth. Step 1. The AI makes a guess. The very first time, that guess is terrible. It might look at a cat and confidently say dog. And that's completely fine. Being wrong is the whole point. Step 2. We check. We compare its guess to the right answer and measure exactly how wrong it was. That gap, the size of its mistake, is the single most important number in all of AI. Step 3. It adjusts. The AI nudges its internal settings a tiny bit, in whatever direction would have made that guess a little less wrong. Just a nudge. Nothing dramatic. Then it does it again. And again. Guess, check, adjust, across millions of examples. Each pass, the mistakes shrink, and that once random brain slowly sharpens into focus. It's exactly how you'd learn to shoot a basketball. Your first shots miss. But each time, your brain quietly tweaks the angle and the power until syncing it becomes automatic. The AI just does this a billion times and never gets tired. This whole repeating process has a name, training. And notice, it's not programming, where a human writes every rule. The AI writes its own rules by practicing on examples until it gets good. That's why AI is so hungry for data. The more examples you feed it, the more patterns it has to practice on, which is exactly why the best models are trained on a huge slice of the entire internet. But what is actually changing inside the AI as it learns? For that, we have to look inside the thing doing the learning, the neural network. A neural network is a giant web of tiny connections, loosely inspired by the brain. And every single connection has a strength. Picture it as a little dial that can be turned up or down. Here's the key idea of the whole episode. Learning isn't some mysterious spark. Learning is literally just adjusting those dials. Every time the AI fixes a mistake, it's turning some of them a tiny bit. And there aren't just a few of these. A modern AI has billions of these dials, sometimes trillions. The exact setting of all of them, together, is everything the AI knows. When the AI gets something wrong, the correction ripples backward through the entire network, nudging every dial that helped cause the mistake. Engineers call this backpropagation, but just picture a wave of tiny tweaks flowing back through the layers. And there's a beautifully simple goal behind it all. Picture the AI's error as a hill, and the AI as a ball trying to roll to the lowest point. Every adjustment is one small roll downhill, toward fewer and fewer mistakes. Do this enough times, and something remarkable happens. That random tangle of connections slowly organizes itself into a clean, structured web that genuinely captures the patterns in your data. And notice what nobody did. Nobody wrote a rulebook for what a cat looks like. No list of whiskers, ears, and tails. The AI built its own definition purely from examples. That's the power of learning instead of programming. Now you can see that every kind of AI is really the same trick. Show a model millions of labeled photos, correcting it each time, and it learns to recognize a cat, a face, even a tumor on a medical scan. Show it endless text with words hidden, and ask it to guess the missing word, over and over. Wrong, adjust, repeat. Now do that across nearly everything humans have ever written. And you get ChatGPT, a model that learned language itself, just by predicting the next word a few trillion times. Same exact loop. Guess, check, adjust. A self-driving car learns the same way from millions of hours of driving. An AI that crushes humans at chess learns the same way from millions of games. The example changes. The loop never does. Guess, measure the error, adjust the dials. That one idea quietly powers almost all of modern AI. Images, text, sound, video, strategy. It's all the same learning engine, just pointed at different kinds of data. Once this clicks, the entire field suddenly makes sense. But there's a catch. Running this loop across billions of dials and trillions of examples takes staggering computing power, vast warehouses of specialized chips, all crunching at once. It also takes real time and money. Training one big model can run for weeks and cost millions of dollars in electricity and hardware. Learning, it turns out, is expensive. And this reveals something most people get wrong. There are really two phases. Training is the slow, costly part, where the AI learns. Using it, called inference, is the fast part, where it just gives you an answer. Here's the surprising bit. Once training ends, the dials freeze. When you chat with an AI, it is not learning from you in real time. It's running on what it already learned, its settings locked in place. Which leads to the most important warning in all of AI. The model only ever knows what it was shown. Feed it flawed data, and it learns the flawed patterns perfectly. If its training data is biased or one-sided, the AI quietly absorbs that bias and mirrors it right back. It isn't being unfair on purpose. It's just faithfully reflecting what it was taught. There's another trap, too. Sometimes an AI just memorizes its examples instead of truly learning them. It looks brilliant on practice questions, then freezes the moment it meets something new. Real learning is the opposite. A well-trained AI doesn't memorize. It generalizes, stretching the patterns it found to handle things it has never seen before. That flexibility is the entire goal. So let's pull it all together. An AI learns by guessing, checking how wrong it was, and adjusting billions of tiny dials, again and again, until its error shrinks close to zero. And remember, none of this involves understanding the way you understand. It's pure mechanism. Numbers flowing through a network, dials tuned by mistakes, patterns locked into place. But done at this scale, billions of dials, trillions of examples, superhuman speed, that simple loop produces something that can feel astonishingly intelligent. And that's the journey. A brain that began as pure random noise, shaped one tiny correction at a time, into something that can see, write, and reason its way through the world. So the next time an AI amazes you, you'll know the real secret. Not magic, not a mind, just a staggering number of tiny adjustments, guided by mistakes, repeated until they became intelligence. You now understand how AI actually learns, something almost nobody using it can explain. That's another real step from zero toward hero. Next, we go inside the network itself to see how it turns all of this into a real answer. Subscribe, and let's keep going together.